Welcome to the Prevent the Preventable podcast, where quite simply, we're on a mission to help you live longer by preventing health complications before they start. Every year, there are millions of cases of brain hemorrhage, but there really doesn't have to be. And at the Natalie Kate Moss Trust, we're committed to ensuring that those that don't have to happen don't. In this podcast, you will learn more about brain hemorrhages, their causes, how to prevent them, and so much more. Expect honest, straightforward conversations that will give you the information you need to take back control of your own health and potentially prevent the preventable. Hello and welcome to today's episode of the Prevent the Preventable podcast. And today we'll be joined by Dr. Katie Murray, a research fellow in the Division of Neuroscience at Manchester University. Now, Katie first became interested in neurovascular plasticity during her PhD at Manchester University, before continuing this line of research over at Yale University in the States. But in 2023, thanks to the funding of the Natalie Kate Moss Trust, Katie returned to Manchester to establish her own independent research group. Katie looks at the effect on small blood vessel bleeds and what happens to the surrounding cells using live advanced imaging techniques. Today, Katie will talk all about her research, the other research projects going on at Manchester University, specifically looking at hemorrhagic stroke, the role NKMT has played in all of this, and what more needs to be done in order to improve the outcomes for patients after they've had a hemorrhagic stroke. If you've ever lost somebody to a brain hemorrhage, I'm sure you've had this overarching sense of hopelessness. But I hope through understanding more about the research being done to find better treatments after somebody has a brain hemorrhage, you'll learn today more about how important this research is. And you'll find that there is hope and something can be done. If you enjoy this episode, please do like and subscribe, as this really does support the growth of the podcast and therefore helps us with our overall mission. But without further ado, let's dive into the episode. Katie, welcome to the Prevent the Preventable podcast. Thank you very much for joining us.
Thank you.
To start us off, can you tell us who you are, why you're here, what do you do in terms of the research at Manchester University?
Yeah, so my name's Katie Murray. I'm a research fellow at the University of Manchester. I've just started my research group last year, and our focus is looking at how different cells in the brain react to a hemorrhage, either a large-scale hemorrhage or a much smaller one, and to look at how they're going to try and clean up this blood and this damage, and go ahead and repair brain tissue afterwards.
Okay, so looking at how the brain can essentially repair itself more than necessarily treatment as well. So, Okay, interesting. So we'll come on to all of that because I think it is very interesting. We had a panel discussion a few weeks ago, wasn't it? And a number of people came up to me afterwards and said just how interesting your work was, which I know surprised you a little bit. But it is incredibly interesting. And so we'll come on to that and we'll talk about that in more detail. Yep. Firstly, let's zoom out and look at the work being done at Manchester University, because 12 years ago, in 2012, my family, mainly my mum and my brother, approached Stuart, who is essentially your boss, Professor Stuart Allan, and asked, is there any research that we could support at the university? And really, in reality, there was none. There was maybe one PhD student doing work on hemorrhagic stroke. That's changed massively over the last 12 years. Can you kind of maybe take us on the journey of that and kind of explain how that has changed over the last 12 years?
Yeah, I think actually, so I was at the university doing my PhD at the time. I was one of Stuart's PhD students. And I remember when your mum and your brother came in, because it really was at the beginning of the trust as well. And I think it was sort of like a collaboration between, you guys were interested, Stuart was too, and Adrian, in sort of moving. We had always focused so much on ischemic stroke. So, when there's a blockage of a blood vessel, depriving blood. But really there was very little being done looking at hemorrhagic. So I think it was really a huge part due to you guys coming in, approaching us. And we kind of thought like, wow, obviously like ischemic stroke accounts for about, 80% of the cases that are coming in. But when we look at it, the 10 or 20% of people who are having hemorrhagic stroke is really disproportionate in terms of the mortality that's associated with it, and then also, the burden that it's going to have going down the line on the NHS and stuff. So I remember when it all first started out, and I think we got a little bit of funding to try and get some models running. I remember being up in the lab with Adrian and Stuart trying to get things going, and we were kind of like, okay, we'll get this model and then we'll try and teach one or two people. And it was still very rudimentary at the time, and the three of us trying to figure stuff out and not really being sure of what we were doing. And then, I left and I went and I did my postdoc. I was in the States for a long time, and I just came back last year. And it's just incredible, to be honest, to see how different it is now. It's a far gone are the days of the three of us trying to manage to get something together. Now it's a team of 25 plus people. My own research group itself is going to be based pretty much solely on hemorrhage research. So in terms of the staff, it's huge. It's totally transformed. I think the vast majority of people in our lab, the brain inflammation group, are working on hemorrhage now. And it's a great group in the sense that it's always been a place where it kind of goes all the way from basic research, people working in cells in a dish, all the way up to clinic.
Yeah.
And again, that's something that I don't think lots of labs do. And that's definitely a big positive associated with the work in the stroke people at Manchester. They've always been good at it. I remember, again, as a PhD student, sitting in lab meetings, and I would have the head of neurosurgery, sitting beside you, being incredibly intimidated. But that's just the way it's always sort of worked with the stroke groups here. So it's not really it's no surprise now to look at the Jefferson Brain Research Center was established a number of years ago. And that was sort of putting what we were doing for a long time into a more established shape. So it's sort of a collaboration now between work at the University of Manchester, the basic research, and then also work with the North Care Alliance NHS Trust. So it's really when we start to see things in the lab, trying to rapidly move that towards the clinic and having less of a divide.
Yeah. I think this is something that's really interesting. We spoke about in this panel discussion that we did have the other week for our partners. And Adam, who did the blood pressure episode on the podcast, mentioned that, so often with research or just generally in the medical field, people work in what he called as silos. And I think what's great about Manchester University is that I'm sure they do exist, but, from what I see, they don't exist. Well, they're not existing as much. And you are able to sit in a meeting next to somebody of, much higher superiority to you and, who maybe not working in the exact same field or, something slightly different. And you can learn from each other and you can share your knowledge rather than just keeping it to yourself. And I think that's where you've seen so much growth as well by huge. Working in partnership. And I think partnerships are, whether it's partnership with NKMT, partnerships with other teams, other departments, it does really help you move forward as well.
It's really huge. And I think, like I said, it's a big component of Manchester. Kind of feel up north as well, maybe that's part of the community. I feel that was a huge part of me wanting to come back, to be honest, because, when I was in the States, I remember we were trying to get some stuff done with clinicians, and even between the clinicians, they weren't really talking to each other. Never mind a basic scientist talking to a clinician. So the lines of communication were never that open. Everyone was being a little bit this is my patch or whatever. And that just doesn't exist here to the same degree.
Do you think it is, obviously with the research in terms of hemorrhagic stroke is not advanced in the way that maybe other conditions or other diseases has over the years. Do you think that's part of the problem maybe?
Yeah, I mean, hemorrhagic stroke is a difficult one in any case. Stroke in general is a tricky one because time and brain, the two are linked so much. And then I think at least maybe with ischemic stroke over the last couple of decades, people have sort of had a better understanding of what the time courses are and these kind of things. And I don't think we're still quite there yet with hemorrhagic. We're still trying to figure out like, oh, when the event happens, is this where it's time point 0? But then if there's a rebleed, you know, are we on a different path entirely? So it's hemorrhagic stroke is just a little bit trickier in that way too. And maybe there could be a component of the lines not being open, but hopefully, you know, with the way that stroke research is going here in Manchester, you know, hopefully that's not going to be the case.
So you actually mentioned right at the beginning, you know, ischemic stroke accounts for, I think you said 80% of all types of stroke. And obviously you've seen advancements in the research around that and the understanding around that. Hemorrhagic stroke has not seen the same advancements. It's not seen, you know, the same advancements as many other conditions as well. So to your point then around not having the same understanding, is it just the understanding, or is it maybe that the same amount of research has not been put into that area?
I think the latter point, 100%.
Yeah. Why is that?
There's always this difficulty of, if something's happening quickly, then there's maybe less interest from pharmaceuticals or something like that to, you know, have their drugs be useful. We've also just not seen much of success from a drug perspective in ischemic stroke. So therefore, I think whilst people are like, oh, a stroke is bad and a ischemic stroke is bad, a hemorrhagic one is worse, certainly in terms of like mortality and disability. So I think people have this negative connotation associated with it, and they're like, oh, well, if these things haven't worked in ischemic stroke and we've tried all these other things, do we even bother?
Yeah. Lack of hope.
I think that's a huge one.
It's really interesting that, isn't it? It's almost like there's no point. It's almost like there's no point in doing it because we're likely to not have a positive outcome. So why waste our time in that area and focus our efforts on something where, not that we can get a quick win, but kind of that point where we can get a win, which I think is so incredibly devastating, I'm sure, for a lot of people who, when they're told that their loved ones had a hemorrhagic stroke and they have that sense of hopelessness and helplessness, you know, that's not even that they feel in themselves, but they can sense from the doctors as well. It just shows how truly devastating this condition is, that we kind of have that, you know, have that feeling around the condition. And that's why I think it's so incredibly exciting, the work that you guys are doing. And as you've just alluded to before, how it has advanced so much over the previous years, over the last decade. Of course, there is so much more to do, but I think, you know, in the terms of, in the timescale of research, you know, you're still extremely early days. And I guess the more that you can do, the more that, you know, we can hopefully find better treatments, improve outcomes for patients. Just kind of like revert back a little bit. So you talk about ischemic stroke, you talk about hemorrhagic stroke in terms of like the difference in terms of cases, but also in terms of mortality rates and also disability rates. For the listeners, can you kind of put those into maybe just rough numbers? Like, what is the difference in terms of like how likely is someone to survive after an ischemic stroke versus maybe a hemorrhagic stroke?
Yeah, so I know certainly for hemorrhagic, survival it's going to be about, well, no, there's going to be mortality of about approximately 40% within the first 30 days. So that's, you know, those numbers are enormous. And like I said, incredibly disproportionate. It's just, yeah, it's much, whereas on the other hand, for ischemic stroke, there's better survival rates for the most part. Yeah, I mean, it's going to be, where it's approaching, I think 15 million people are having a stroke of whatever type. So those numbers, and they're only increasing, you know, really. And that's either advanced age, but also cardiovascular diseases contribute enormously to people having these incidents. And so I think the numbers are only going to increase as time goes on.
And those cardiovascular, you know, reasons, conditions that people have that are contributing to somebody having a stroke is largely due to lifestyle?
Yeah, I mean, hypertension is one, absolutely, like the leading cause far and away. And then, lesser parts, diabetes or high cholesterol. Just for the most part, it really is, it is lifestyle.
Yeah.
And our blood vessels just are, they kind of have a memory of those things. And it's just a slow, gradual, things get worse. I've worked with blood vessels in normal, looking at both brains, human brains, or from animal models and stuff. And it really is incredible, the difference, the amount of elasticity that you see in these blood vessels in a let's say a mouse that has high blood pressure versus a normal and healthy one. They almost like seize up.
When they have high blood pressure.
When you've got high blood pressure, and then if you cause a trauma, so let's say that there's a clot there or there's a bleed there, everything seizes up in the ones that have had high blood pressure or aged or those kind of things, versus the normal and healthy ones, which are much more capable of constricting and dilating as needed. So it all builds up over time.
Yeah, I think that's where, as a charity, but also in terms of this podcast, we try and talk about the fact that it's not just about, having high blood pressure and then, that would almost cause the bleed. It's also the damage that creates over time that then reduces your body's or your blood vessels' ability. To manage that situation.
Yeah, definitely. So what you really want actually is, after there is a bleed, you almost want like a bit of constriction. You want to stop all of this, the burst pipe from going everywhere.
Yeah.
So you want to kind of hold it down for a little bit. And that is a normal reaction of the blood vessels to do. But if over the course of 10 or 20 years, you've had these comorbidities that are causing your blood vessels to not really have that same ability to open and close, that pipe is going to bleed, and it's going to be much harder to recover after that.
Yeah, this is why I think, just the management of blood pressure is just so critical. And I think we talk about this with, we go out and do these events and talks and whatnot, and some people take it really seriously, and some people are almost see it as, this light joke, or whether they're making light of it because of a bit of an ostrich effect. They're putting their heads in the sand, but quite often people do put their head in the sand, and whether you put your head in the sand or not, you can't escape the fact of the effect it's having on your body. And I think whilst it's hard to hear, I think the reminders from people like yourselves, or whether it was from Adam in our blood pressure episode, of the importance of this, because it is such for most people, it is a simple tweak in lifestyle. You've just said most of the problems are due to lifestyle. So if we can manage them, we can hopefully support us down the line too. So, and obviously that's prevention. Yeah. And what we want to speak to you is kind of the after somebody has a brain hemorrhage, what can we do so there isn't that hopelessness, that we can offer some hope that, things can change and the outcome can improve, because as you mentioned, it's pretty bleak at the moment if somebody does have a brain hemorrhage. So going back to the research, and specifically your research, because there are many projects and we can maybe touch on a few of them, but what are you doing specifically in your work?
So I've always been interested in using imaging as a way of looking at damage to the brain. Back in my PhD days, I did MRI and a little bit of PET scanning. So that's when you can kind of take a more global look at the brain when there's like a big insult. And that was good. But I remember always getting critiqued on, if you took a magnifying glass and really took a look at what was going on and zoomed in on these cells, what would be going on? So I did my postdoc, I did later research using this sort of imaging method, where you can actually, in a mouse model, you can remove a very small part of the skull and put in a piece of glass. And then use microscopes.
Must have been a very small piece of glass to put it in a mouse.
So you use like a little dental drill that you would get your fillings done with. And you just, I think it's 4 millimeters by 4 millimeters, just like pop it out, stick that piece of glass in, and then, you can look at the brain for the entirety of the whole life of that mouse then. So what I'm interested in looking at is to then induce hemorrhages within the brain tissue, and to be able to look down through this glass window and to visualize what all the cells are doing in and around that bleed. So we're able to like label cells with different colors, and we're able to induce microhemorrhages. I think sometimes the things that we do in the lab sometimes are almost like a snapshot of the disease, whereas the techniques that I'm using, we can look at it in real time. So we can keep on coming back and see, oh, this bleed got smaller and smaller, or something else happened. So that's like a big innovation that actually I don't think has really been applied to, definitely not been applied to hemorrhage models before. So it's very new to sort of like look at hemorrhage under such
Real
a sort of
time.
like in real time, like almost with like high resolution microscopes with a magnifying glass.
A huge thank you to Colony Co-working for supporting us with this first series of the Prevent the Preventable podcast, and for providing us with this beautiful studio too. Now, at the Natalie Kate Moss Trust, we are a small team working remotely, but on a mission to make a big difference. But finding the balance between flexible working and working in inspiring spaces surrounded by inspiring people can be a hard balance to strike sometimes. Colony is an expanding network of co-working spaces in Manchester, a place for entrepreneurs, creatives, freelancers, startups, and established businesses. A place where everyone comes together, where ideas pollinate and businesses flourish. And Colony is helping NKMT do just that by supporting us with this podcast, by helping us reach more people with this vital message, and ultimately helping us to prevent the preventable. To find out more about how Colony can help your business grow, head to the show notes now. And is that something that you like foresee being able to be used on a human, in a sense of having that same technique?
Not so much. So the thought is that I'm gonna sort of use a combination approach. So I'm interested specifically in something called myelin, which is this fatty substance that it wraps around all of the neurons of your brain, and it actually makes the signals in your brain move faster. The more myelin you have, the better, the quicker it is that you get these signals that move through the brain. Whenever there's an insult, the myelin kind of breaks down. So then things don't, it's harder to make connections. This could affect memory, speech, motor, anything. So I'm interested then in looking at how much of the myelin is broken down when there's a bleed there, and how it comes back over time, because the brain does have the capacity to sort of repair itself. So I want to look at that through these windows to understand the sort of like the nitty gritty of what are each of these cells doing. And then once we have an idea about which cells are most important, almost to try and get a time course of what's going on. We induce the bleed. Who's the first responder? Who's like the paramedic to the situation? So we have ideas about the certain cells that they're like the bin men, and they come in and they start cleaning up. But then they get full, and they can't do too much. And then there are other cells who can sort of like take half the load too. So we're going to look at how all of these cells work together over time. And then once we've really characterized this approach on a cellular level, then we'll apply it to a larger hemorrhage. So we can actually induce, sort of like with the methods that people are using at the moment, inducing larger bleeds, and trying to sort of therapeutically target cells to, again, maybe clean up the blood at certain time points. Like once we know the time course, then we can act a little bit more.
Yeah, I suppose if you can understand what's really, you can only change something once you fully understand it, right? So then is the view to go, okay, well, we know that this cell is doing that and cell B is doing that. And maybe if cell C came in a little bit earlier or whatnot, that could help.
100%.
Would then the idea be to create a treatment that triggered cell C to act earlier, as an example?
Sure. Yeah, absolutely. And to be using the treatments that we potentially identify at the right times as well. Because, what's the point in giving a drug really early when maybe that pathway isn't happening then, or maybe that's just not the right time point at all, or it's the wrong cell. So if we can understand the disease over time and the cells that are involved, then we have a better chance trying to use some sort of therapies to modulate it.
That's really interesting. Assuming then that there are a number of different, well, many nuances, I assume, within that, such as the age of the person, again, whether they have hypertension, where the bleed is in the brain, you know, is it on the surface, is it deep within the brain, you know, all of these different points, where maybe the cause, AVMs, all these different things, assuming they would all make it more complicated and different as well.
Yeah, definitely. But I do feel like we're beginning to, I feel like it's a bit of a renaissance for hemorrhage research in some ways. I think we're starting to look at it with the same sort of granular approach that we used to do with ischemic stroke. And honestly, I think that gives me a lot of hope in terms of when we take the same sort of rigorous approach to doing things, well, absolutely, we're going to make some advances. You know, scientists have done incredible things and people are really smart. And if we just...
And you guys are really smart. I've all met you guys a few times. You are.
But like, you know, if we put our minds to it and not have this helpless approach that sometimes is associated with the disease, then absolutely I feel like there could be huge breakthroughs that come along with it.
Yeah, I agree. And I think that word helpless, I think, is really interesting, because when I've spoken to one of the researchers, or clinician researcher, Adrian Parry-Jones, who obviously you've mentioned already on the podcast, he mentioned about this helplessness feeling within hospitals as well, and administering treatment, which is where where a treatment that he's developed has now kind of come from, really, the ABC bundle. Can you kind of just give us a summary of what that treatment is, and when I talk about this helplessness feeling, what I'm alluding to?
Yeah, so, you know, like we had spoken about before, it would almost was like if the clinician, if they thought that the patient was coming in with a hemorrhage, it was this sort of like, well, we're just going to wait and see. And that was the only approach that people were going to take. And what Adrian has identified and implemented now is ABC, which is, first of all, they want to, you know, reverse the coagulants that they're using, anticoagulants that are being used, so that you don't get excessive bleeding. You want to then reduce blood pressure very quickly, because again, it's kind of linking back to the thing that I was saying about before with you want to stop too much blood from getting out. So if you lower blood pressure, there's less that's being pumped around. There's then maybe less that's going to leak out. And then to just have a really specific care bundle in mind, and so that the patients are then going to either be referred to surgery, or they're going to go whichever direction that they need to go to after that. So that's what the ABC really lines up. And frankly, I think it's just incredible, the success of it. I'd actually kind of forgotten a little bit, or I hadn't read the paper in a while. And then I was teaching a tutorial at Manchester a couple of weeks ago, and I had to give a couple of different papers to the students to read. And we had some sort of like standard stroke papers where a drug was given or whatever. And then I gave them the paper that Adrian's work was on. And of all the different papers, when I looked at the results, the greatest success was seen from the ABC bundle versus other papers where they had looked at, oh, we gave this drug, or we did this surgical thing, or we did all of these heroic measures.
And what's the success rate with it?
I think it was something like a third sort of reduction in mortality by a third.
Yeah,
which that's mind blowing in a
medical
in any sort of scientific sense. You know, many times when we do experiments, like if we see 15% or 20% change, that's great.
Yeah.
But to see, you know, a third less people dying is just incredible.
I think what I found most interesting as well about it is that, you know, it's kind of so simple.
Yeah.
And that's where I think it's fascinating, you know, just stop doing this, or lower blood pressure, and make sure they're getting, as you say, the right care pathways. It's not super complicated. It's not this, you know, all fancy new treatment and drugs and etc. It's very simple, but it comes down to administering it and doing it quickly and doing it well. You mentioned as well, time equals brain. So making sure that those things are being done quickly and well. But I think, you know, when we talked about the hopelessness piece before, as you say, people just feel a bit like, oh, nothing can be done. They're not going to be necessarily quick to act.
Right.
So I think, if we can, roll this out, and as well as other treatments, as well as, there's probably some nuanced things within the ABC bundle that need to be kind of tweaked, which we've discussed with Manchester University, but it's a huge advancement. And this is why it's so exciting. You talked at the very beginning of this podcast about how you, Adrian, and Stuart kind of in the lab kind of bundling around and getting things together at the start of any business or any venture. And to now kind of this to come out of that is so immensely exciting.
And that was only in a decade, really, which again, in science terms, is a blink of the eye. So I think it really is, I think it's an empowering, what they've done has been empowering for both clinicians, but I think also maybe nurses, everyone who's part of that healthcare team, paramedics, whatever, now that they know, like, we're doing X, Y, Z, we're doing it in this time frame. I think everyone can be on board with that.
I guess there's a massive challenge though, getting anything out into the NHS in terms of getting that message across to, as you say, all those different touch points, the nurses, the paramedics, the doctors, the neuroscientists, getting that message out there, getting it done well, exactly. The funding, all of the different points. It's a huge establishment, and I guess there's a few hurdles to overcome there as well.
100%. Yeah, no, there definitely are. But also, kind of like as you alluded to, there's still lots that can be done within that. I was, after we had the breakfast recently, I just went across the street and grabbed a coffee, and Adrian was in there getting a coffee as well. And we started talking about some stuff and like linking up the research. And I think there's definitely things that he's talking about doing in terms of the part C of that package, and that we can almost parallel with what we're doing in the lab too.
But again, going back to your point, this is where it's so great that you have all these different parts of the research. He's more on the clinician side, you're in the labs, working together to really kind of move things forward too. So in terms of the other research going on, are there any other sort of ones that sort of standout research projects that we can mention and kind of let the listeners know about as well?
Yeah, so I mean, there's always lots of mouse research going on within our group, because that's something that we're definitely experts with, doing a lot of MRI, testing different drugs, potentially. There's also using zebrafish as a model as well, that you can induce hemorrhage.
Which, if the listeners don't know, are like, I don't know, they're probably not even a third of a fingernail, sort of your little fingernail. They're the tiniest fish. Which obviously, then have the tiniest brain. And you guys somehow manage to kind of, explore their brain and what's going on in it. It's quite incredible. A huge thank you to Hugh James Solicitors for sponsoring this first series of the Prevent the Preventable podcast. Now, having your life torn apart by a brain hemorrhage is one thing, but learning that it could have been prevented and it was due to a mistake in your medical treatment is truly devastating. And whilst nothing can change what has happened, Hugh James's clinical negligence team can support those who have suffered a brain injury or bereavement due to a mistake in their treatment. To find out more about how and if they can support you, head to our show notes now.
Yeah, it's almost like the zebrafish pathology is spread up versus mouse or human. So in a fish, the time course is much shorter than in a mouse. It's a little bit longer, and in a human, it's much longer again. And it's always interesting, like a hemorrhage in a mouse, they can often survive and do okay afterwards, and the same size and hemorrhage in a human is fatal. So it's really understanding some of those. That's why I think it's really interesting and complementary to have multiple organisms that you're looking at, multiple drugs that you're using. It's all informative, it's all complementary. And certainly in terms of like what we're looking to do going forward, we're definitely interested in some of this myelin stuff that I was talking about. I'm interested in looking at where these bleeds happen. So again, like looking at hemorrhage with much more granularity, not just saying like, okay, there's been a bleed, we're gonna do a scan or something, but really like go down and say, okay, if this bleed is happening here, maybe we're gonna do X. if it's happening over here, we might do Y. And I think what Adrian's looking at doing as well is kind of complementary to that. And they can see through some of the scans, if this is the location of where the bleed is, that's
The
going
treatment
to
would be
inform
different.
us. Yeah, 100%.
Yeah, because at the moment it would be a bit of a blanket treatment, would you say?
Yeah, I mean, again, oftentimes there is this sort of like wait and see approach,
Yeah.
and it's hard to. There are some cases that do work for surgery to evacuate the bleed. I don't think there's always like a definitive we should do it or we shouldn't do it. But what we're looking at doing now is part of that bundle when it comes to like deciding. Let's have a really rigorous way of deciding. This is a good candidate for this surgery. This one's going to do better if we don't.
Yeah.
And I think we're gonna parallel some of that as well with the mouse work.
Yeah. Yeah.
And have it.
And that's really interesting. And I think I spoke to your boss, we've already mentioned Stuart the other week, and they were talking about also, using AI, in terms of overlaying certain imaging techniques, whether it's MRI or whatever, to kind of help inform decisions as well. And I think it's this utilizing these different tools and these different treatments and these different understandings and what's happening in the brain at what point, the more you can build out of a picture, the more you can better understand what the course of action is
100%.
there, which I think is really exciting. So I guess the more research projects you can have going on within your team, the more people who are looking at whether it's what's happening to the brain during a hemorrhage, or how does the brain respond to this type of treatment, or how do we improve, imaging techniques or whatever it is, the better we can build that picture and then build the course of action after that. 100%.
And I mean, for me, obviously it's huge, the funding that I've got to start my research group now, and it's incredibly exciting to think that this is going to be a whole new lab that's going to start, and it's going to be totally focused on brain hemorrhage research. But absolutely, there's so many things that we can do potentially. Again, linking back to this sort of like AI and maybe like the repair. How does the brain repair afterwards? If we have a better understanding of how this myelin, which wraps around your nerves, reforms. Again, we could use AI, computational methods to sort of like go further and think about, how it's doing it in different areas or whatever. So there's so much scope.
Yeah,
really.
You just need more people, more resources.
Yeah. I think it's going to be more people, and it will definitely make a difference. But it's exciting nonetheless.
Yeah. So what's next for you then in terms of your research?
Yeah. So it's going to be lots more imaging. We're going to be doing some of these windows, looking at how this myelin is changing over time. Really working hard to try and correlate with what we're seeing with the clinic as well. And I mean, again, in an ideal world, once we've sort of characterized what we think is happening in the immediate aftermath, who are in the important players, or who's, I think I mentioned this to you before, like I think it's really important to look at cells in a intact environment. So that's what these windows allow us to do. We're really looking at the cells in an uninterrupted state, and it is like looking through someone's front living room window into what's going on in someone's house and seeing how everyone interacts together, uninterrupted. So I think once we've characterized that, then definitely looking at potentially therapeutics, treatment options. I think there's definitely some to sort of like stop iron overload, those kind of things. So we can test them all and see, we'll look through these windows, we'll give the drugs. Does it change the way that they've acted, the cells, to the bleed? Does it speed up the way that they're cleaning it up? Does it do something worse?
Yeah.
So there's certainly, it's, like I said, I don't think anyone's really used these methods to look at hemorrhage before. So it feels pretty exciting to kick it all off.
Yeah. I think it is very exciting. And, as we've spoken about, there's already been advancements. As you say, 10 years is a blink of an eye in research terms. And there's already been huge steps forward. And it's so exciting what you guys are doing. There's so much to do still, but there's so much more to come, which I think, to go back to our point about people feeling hopeless, like they don't need to feel that way anymore, or hopefully not. You know, there are things that we're doing now, or you guys are doing, to change that. And that's what all the work that we do, and obviously all the work that you do, is like ultimately changing that landscape, because you know the statistics, as you pointed out before, around hemorrhagic stroke are really devastating, and enough hasn't been done. So something needs to be done, and I think somebody's got to do it.
Yeah.
So I think the work that you're doing is so incredibly exciting, and we might be sat here in 10 years time and talking about a whole different world of brain hemorrhages, hopefully.
I feel like it's guaranteed almost, really. When you've got and this is only our group, you know, if you've got 30 people sitting down and working every day on a topic, then surely.
Yeah. And if you look at the growth that you guys have had over the last 10 years, you know, that growth will hopefully multiply. And, you know, the Jefferson Brain Research Centre, the Centre of Excellence for Brain Research that has been set up now at Manchester University, you know, we don't know where that's going to go, but it's only going to move forward and keep growing and keep building. So, and hopefully that does bring the, you know, the best minds back to, you know, Manchester. And, you know, hopefully we'll now see this beautiful knock-on effect as well. So.
Yeah, it's interesting, actually. I spoke to a couple other people who were sort of in my same situation. We had all gone to the US and came back, and we were talking about it, and we're like, it's good to remind sort of like the junior scientists that like we really are. We've gone and we've seen what other people are doing and other places are doing, and in our experience, we're doing the exact as good a research as anywhere else. 100%. There's no question about it. And we shouldn't have a sort of like a chip on our shoulder or whatever. You know, we're doing really incredible stuff, and to appreciate that, you know, it's just as good, if not better, than lots of places.
Yeah. So if there's any young budding neuroscientists out there, they want to be in the best place, come to Manchester.
Totally.
Katie, thank you so much. I think hopefully the listeners have not only learned about the research, but as I said, kind of gained some hope that, you know, things are changing. So obviously you've spoken about the treatment. We've got a few quick fire closing questions, which some of them are a bit more about prevention, let's say, and lifestyle. But the first one is, what is one non-negotiable for you in your routine, your habits, and your life that you know is supporting your health?
I've kind of got two, I think. I'm a big sports fan, not a gym fan. I haven't had a gym membership in 15 years, but I love sports. So I have to always be a part of a team or something. I've actually got 2 netball games later today.
2?
Yes.
Oh, wow.
Yeah. Yeah. It's a good like stress buster.
Yeah.
And then I think the other one is like sleep. Good sleep for me is, it doesn't have to be 12 hours. I mean, I wish that would be great, but just getting good sleep.
Yeah.
So that's a strict one for me. You know, the cat has to stay out in the other room. Like,
well, we had an episode actually we released last week, but you know, it's episode 3, I think it is, but all about sleep, because I think sleep doesn't get enough airtime, in my opinion, but yet it underpins everything. If we don't sleep well, we're probably not going to exercise. We're probably going to be stressed. We're not going to eat well. We might, you know, drink alcohol or whatever. There's this knock-on effect. Whereas not only are the physiological benefits you have when you sleep and your body, you know, sorts itself out, but also the knock-on effect it has with the rest of your lifestyle. 100%. So couldn't agree more with you on that. If you could get more people to understand one thing, what would it be?
I think appreciating the importance of doing the little things or doing the smaller task. And again, it's, as you kind of mentioned about the ostrich effect, not when it comes to the small things, don't do the ostrich thing. You know, if it is like the checkups, if it is just checking, I've got a little blood pressure cuff at home, just doing the small checks, it really can save you a lot of hassle, pain, all those things in the long run. And I think it's oftentimes easier said than done. And I'm only thinking of it in terms of like my parents who are getting older and trying to persuade them, you know.
We all have that problem.
I think so. But it's just like, if you just went and did these things, then we wouldn't have to worry about other things. So I do try, now that I see it, you know, with my parents and stuff, I'm trying to be more proactive about going for my checks, doing the things that I, know that I should do, because I think it saves people in the long run.
Yeah. It's an investment.
Yeah.
So, yeah, absolutely. Finally, do you have a motto for life? And if so, what is it?
Well, I think as a general all over, just, being kind, because you never know what people are going through. But I think something I've been thinking about recently from a work perspective is progress over perfection. And it's easier said than done.
Yeah.
And I think certain personality types find it trickier than others. But I've really been trying to work harder about, it doesn't have to be the most perfect thing ever. Just checking things off your list. Again, it's like avoiding procrastination almost. And actually, believe it or not, I think the first time I heard that phrase was from a neurosurgeon.
Wow.
Which was
we talked about hope.
Which was such a shock, for a surgeon to be like, if something's good enough. Yeah. But it's true. And so from a surgery perspective, it was like, don't continue to try and get the most perfect thing, because that's when you might get like an unexpected bleed, or you might get something.
That's really interesting.
Yeah, it really was. And it really stuck with me. And obviously I kind of thought like, oh, well, if a neurosurgeon can take that approach, I can take that approach to doing my emails. So
you start fiddling too much.
Yeah.
You create a problem.
Yeah.
It's really interesting, actually.
Yeah. So that's definitely something I'm constantly trying to work towards a little bit.
Yeah, I think we can all take a lesson from that.
Yeah.
Katie, thank you very much.
Thanks for having me. It was great.
I really hope that you enjoyed today's episode and now have a much better understanding about the research being done at Manchester University and just how important it is. And to find out more about that research, head to our show notes. And if you enjoyed today's episode, please do like and subscribe, as this really does support the growth of the podcast. Now, as you heard today, this research being done at Manchester University is groundbreaking, and it is so incredibly vital in order for us to move forward with regards to brain hemorrhage treatment. But in order for us to move this research forward, it needs funding. And so if you would like to support this research, head to the link in our show notes where you can find a link to donate. Even just £5 will make a world of difference. Thank you so much for listening today. And until next time, have a great week.